morning. Today we are going to see Newton's second law is the real law of motion, or derive Newton's first law and third law from second law. In last class we have seen Newton's second law. Now we are going to prove that Newton's second law is the real law of motion. That means we can derive first law and third law from Newton's second law. Therefore, it is called real law of motion. It doesn't mean first law is not important, third law is not important. From second law, you can derive both first law and third law. That is the meaning of this derivation, this class. Okay. What we have seen last class? We have seen F is equal to dp by dt. That means second law. That means Newton's second law states that the rate of change of momentum is equal to the applied external force. Okay. Rate of change of momentum is equal to applied external force. And also we derived F is equal to mass into acceleration. We derived force F is equal to mass into acceleration. Okay. Now this is also Newton's second law, and this is also another form of Newton's second law. Now we are going to obtain Newton's first law. We are going to obtain Newton's first law from this equation. Okay. How we are going to obtain that? Let us see now. Okay. What is Newton's first law? Newton's first law is every body continues in its state of rest or uniform motion unless there is no external force. Okay. That means if there is no force, then only the body will be at rest or in uniform motion. If there is a force, then you are disturbing the resting position. If there is a force, you are disturbing the uniform motion. That means what is the condition? If there is no force, then only it will be at rest. Then only it will be in uniform motion. That means the first condition is if there is no force. That means if F is equal to 0. If F is equal to 0. That means if there is no force. Okay. Then this equation becomes 0 is equal to mass into acceleration. Okay. We are first defining second law. After that, we are applying the second law to the first law. Okay. Now, when there is no force, then F is equal to 0. Therefore, mass into acceleration is equal to 0. And you know, mass m is constant. Okay. Therefore, it cannot be equal to 0. Okay. This is an equation. In this equation, either this should be 0 or this should be 0, because it is a multiplication. Okay. It is a multiplication. Therefore, either this term or this letter should be equal to 0. But you know, mass cannot be 0. Every object has an fixed mass. Therefore, m is not equal to 0. That means A is equal to 0. Okay. That means A is equal to 0. Okay. What is the meaning of this? What is the conclusion? If A is 0. Okay. When a body is at rest, okay, then there is no acceleration. Okay. If a body is at rest, there is no acceleration. Okay. That means A is 0 means the body is at rest. In the first law, what we are saying, every body continues in its state of rest. Okay. That means when there is no force, when there is a force, then resting position will be changing. When there is no force, it will be at rest only. Here we mentioned F equal to 0. Therefore, A equal to 0. That means first condition, the body is at rest. Second one, if the body is in uniform motion, then also there is no acceleration. That means uniform motion, okay, then there is no acceleration. Acceleration, I think last class we have defined, okay, acceleration equal to dv by dt, dv by dt. Last class I have defined. That means in a uniform velocity there is no acceleration, because in uniform velocity there is no change in velocity. If there is a change in velocity, then only acceleration will be there. But here acceleration is zero. That means the body is in uniform motion, or the body is at rest. Under what condition? When there is no force. Okay. When there is no force, there is no acceleration. There is no acceleration means the body is at rest, or the body is in uniform motion. That means we have explained Newton's first law from Newton's second law. We have taken Newton's second law and we proved when there is no force, the body is at rest or the body is in uniform motion. Now let us see Newton's third law from Newton's second law. Okay. For that, let us consider an isolated system. Let us consider an isolated system. What is meant by an isolated system? Isolated system means, now in this class, I am teaching and you are listening. That means we both are in a room. Okay, students are sitting and I am teaching and you are listening to me. We two are in interaction. The door is closed and there nobody is entering. Therefore, this room is an isolated room. We two are in interaction. Just like consider two objects, okay, A and B. Okay. Now this square, that means it is an isolated system. Two objects are in an isolated system and both are moving with a velocity and they collide. Okay. A and B are having masses m1 and m2 and both are colliding each other. Okay, there is no external force. Both are colliding. Okay, it is an isolated system. Now, this object, that is the object A or the sphere A, exert a force on object B. Okay, or sphere B. That is called F1. Okay, that means F1 is a force which acts on the sphere B. And in turn, B also exert a force, okay, according to Newton's third law. Okay, B also exerting a force which is F2, okay, which is on body A. Okay, therefore F1 is a force acting on B and F2 is a force acting on A. Okay, and again we take the same formula. And Newton's third law, already you know this. Okay, it is a very, very basic concept. Okay, every action has an equal and opposite reaction. Okay, F1 is equal to minus F2. Okay, that already you know the concept. Now, here again I take the same formula, F equal to dP by dt. F equal to dP by dt. Now here dP is change in momentum I told, and dt is the time and F is the force. Now you cross multiply. Therefore, F into dt equal to dP. That means change in momentum. Okay, F into dt equal to change in momentum. Now, due to this collision, the velocity may change for A as well as for B. Therefore, change in momentum of this particle or this object or this sphere and the change in momentum of this sphere you can write. That means dP1 you can write, dP2 you can write. For one particle dP1, another particle dP2. Therefore, you can write change in momentum. Okay, change in momentum equal to, you can write F1 into dt of sphere B. Okay, change in momentum of B. And similarly, change in momentum of A equal to F2 dt. Okay, these two are change in momentum. Now you can write total change in momentum. What is the total change in momentum? Total change in momentum equal to total change in momentum is equal to F1 dt plus F2 dt. This is total change in momentum. Now I erase this. Okay. Now total change in momentum. Actually, what is second law? The rate of change of momentum is equal to external force. Okay. If there is a external force, then only change in momentum will be there. Now here, these two objects or two spheres are in isolated system. Therefore, there is no external force. There is no external force. Only body A has an energy and it collides with B. And B has an energy, it collides with A. Okay, that means there is no external force in this system. Therefore, what you can write is, you can write F1 dt is, plus F2 dt, which is equal to 0. That means total change in momentum equal to this much. Okay. Now total change in momentum is caused by external force only. If there is no external force, okay, then it is 0. Therefore, change in momentum is equal to 0. Now you can take either this or this to the another side. Therefore, if you take F1 dt equal to minus F2 dt, that means you are taking this to another side. Now it becomes minus. Now collision is taking place at the same time. Okay, collision, A is moving and B is moving. Okay, or both may be moving in the same direction. It is not a problem. Okay, therefore collision is occurring at the same time. Therefore, you can cancel the time. You can cancel the time. Therefore, F1 is equal to F2. Okay, that means F1 is equal to minus F2. F1 is a force, okay, and which is equal to minus of F2. That is, every action has an equal and opposite reaction. That means we have taken F equal to dp by dt and we cross multiplied and dp equal to F into dt. Okay, that means change in momentum equal to F1 F into dt. Then what we have taken? We have taken two spheres in an isolated system, and one is exerting a force on another, another is exerting a force on another. Okay, and we have taken momentum of one and momentum of another, and we have taken total change in momentum. Then if there is no external force, then this is equal to 0. Then we are taking one to another, and both the collisions are taking place at the same time. Or collision is taking place at the same time. Therefore, cancelling dt, you are getting F1 equal to F2. This is Newton's third law. We have taken Newton's second law and we obtained Newton's third law. Therefore, we are saying Newton's second law is the real law of motion, and we derived both the first law and the third law from second law only. It is a big question. They are asking for 6 to 7 marks. Thank you.